Hi, I'm Jim Caranta, and today I'm going to be doing a build video of the NixieKits.eu Numitron clock built with Numitron tubes. Now there's an excellent build video done by Ian Sparks on Tube Clock Database, but I'll be building mine in a different order and doing some comparisons against a Nixie tube clock that I built from the same vendor. So with that, let's get on with it. Okay, so this is not the clock we'll be building, but this is another clock that I built from NixieKits.eu. But I did want to show you, some key differences between this clock and the Numiqueen Numitron clock. This is the Lena kit, and it comes with 4 ion 12 Nixie tubes and then 2 of the smaller ion 17 tubes. But this is when you get the board, and we'll do a kind of a comparison on the boards in a little bit. This runs on high voltage, and so there's more complexity on the board, whereas the Numiqueen clock's low voltage. We'll talk about that a little bit more. But I just love the lines on this clock. I built this one maybe 3 years ago, and my daughter really liked it, so I built one for her. Really great clock. Love this guy. So just taking a look at the tubes. So this is a Nixie ion 12 tube. And so I don't know if you can really see, but the way the Nixie tubes work, they run on high voltage, and there's basically gas. I think it's a neon gas in the tube. So it's not really a vacuum tube. It's full of neon gas. And when the pins, the pins are connected, so, each of the wired numerals will be energized, and you basically get a plasma glow, off of the numerals. And it's a really nice color to look at. It's very interesting to see, how they move through the, kind of a 3D effect with the tube. So these are no longer made, but they're pretty easy to find. They're not that expensive. Whereas the Numitron tubes are actual vacuum tubes. These are really difficult to find, much more expensive. I think when Ian made his video, you could find tubes for about $30-35 a tube. I had to spend $50 a tube for this kit. Very, very hard to find. But they do have a 50,000 hour lifespan rated, so you're going to really probably get much longer than that. So these tubes will last a really long time. I don't know what the rated lifespan is on the Nixies, but it's much longer than that. So these have filaments that glow. So you'll still get an orange glow, but they're filaments that glow in here. Really beautiful tubes. So I'm looking forward to getting a clock together with these tubes. Okay, this is a comparison of the Nixie board from the Lena. So the Nixie tubes, as I mentioned, run on high voltage. I think it's about 170 volts. You can see a little warning there, caution high voltage. So this is a more complex design, and the board will come with the surface mount capacitors pre-installed. You need to look these over, and you might need to touch up a few that are loose. But most of the surface mount work is done. And you have 2 boards. This is the main board, the display board. So when you put the tubes in, you'll use additional pin sockets and kind of build your own socket. So after you're done with the kit, you can remove the ion 12 tubes because they'll end up being socketed. But the ion 17 tubes, they're not socketed. Those are just wired in directly. So when those go out, it's going to be a little bit of work to clean up those holes to replace those tubes. Whereas the Numiqueen Numitron clock board is larger, the tubes go on top, but it's a simpler design. There are no surface mount components. There's a couple that you have to add, but they're larger. But the far majority of these are just standard through-hole components. And we'll go over the schematic in a little bit, but it is a simpler design. Okay, let's do a quick schematic review. Like I said, this is a simpler design compared to the Nixie clock. It didn't take me too long to figure this out. I am just a hobbyist when it comes to electronics. I am not an expert. takes me a long time to understand schematics, but this one was pretty straightforward. Got a head start with Ian Sparks, so I appreciate his review as well. So just wanted to talk about kind of the major sections. So, here is the, the power in, and this is the voltage regulator, and we're going to get, 7 volts that are going to go drive the LEDs, but most of the rest of the components are driven with 5.3 volts. So we'll have the voltage regulator and a power LED here, and surrounding capacitors. So if we look at the next major section, we'll come up here to the main microprocessor. So we have the 5.3 input, and then we'll have the PIC microprocessor. And we just kind of take a look at the pins. There's your power coming in. We have some input pins coming from the various buttons, one for daylight savings, alarm, adjust, and set. So these are the input pins. There's an output to an LED, data LED. There are 2 pins that are taking signals from the quartz crystal for timekeeping. There's an output pin to a speaker for beeping. And if we come over here, there's another LED. This one is for, looks like daylight savings time LED. So that's a daylight savings time indicator here. Then we have some power power and control. This is actually control to some LEDs that go underneath the Numitron tubes, for lighting effects. The power is actually coming here. There's a 7 volts are coming from here, I believe. And that's going to drive a series of LEDs that will be placed, underneath the Numitron tubes for effects. And these are really kind of optional. If you don't like them, you don't need them. And you can order whatever color you want. There's also a set that comes with revolving colors that kind of rotate through different colors. I normally like that, but in this kit, each of the LEDs kind of rotated through their colors separately, versus the Lena clock, the color cycling, they were all done in unison. So I didn't like the independent cycling of the color, so I just have plain amber lights for my kit. Then there's a temperature sensor input. So this is the temperature sensor that comes in, and there's an option to wire that sensor with wires and move the sensor further away from the clock. So this will actually be on the clock, and the clock gets a little warm, so it skews the temperature readings. So if you wanted accurate temperature, you could wire it up through some wires and keep the sensor away from the clock. I'm not going to bother doing that. I'm just going to put it on the clock. They do have you mount it under the board instead of the top to kind of minimize the heat, but apparently it will skew the heat. Will skew the readings. And then we have the output pins that control the display. So there's 4 outputs here. I'm not exactly sure what they all do, what the meanings of these descriptors are. But if we take a look, most of them are routed in parallel to the tube drivers. So there's 4 ICs that drive the actual tubes. They're all in parallel except for this SD input pin, which comes from DTA. So this DTA comes into SD in, and there's an SD out. It's number 14, and this one's kind of daisy chained, through all of the tubes, or all of the drivers, I should say. The rest of them are in parallel, and then they interface directly into the tubes. And there's some optional connections if you want to add some LEDs for the colons for the clock. I'm going to use the display ones that come on the tube, so I won't be using those optional connectors. And then there's a section in the middle I kind of skipped over. This is the optional if you wanted to use GPS, the GPS time input module, which is an optional module. I didn't order that, so I won't be using this section here. And that's pretty much it. All right, we'll start the build. All right, there's not much here for instructions. Top half is German, bottom half is English. This is really it. but there is an order specified here. The parts lists are clearly marked. In the back, we've got a really good kind of part list. You know, all of the codes are listed on the schematic and are listed on the board, so it's pretty easy to map those together. In terms of the order, I've seen some folks, you know, put this. I guess some folks have a certain order that they like to do, so they debug along the way. I really don't know enough about electronics and IC to trust myself to do that. I know Jürgen, who makes these kits, you know, at certain points of the build, he has you test the pins of the socket to make sure that they are at a certain voltage before you plug the actual IC in. So I'm a little reluctant to, you know, plug the IC in and kind of build around it. So I'm just going to kind of put this together the dumb way. I'll start with all the small components, the resistors, and just kind of follow the order here. In here, there's a point where you need to test, you know, if certain pins, here we go, measure the voltage at C17. It must be the range of 5.1 and 5.3. If that's okay, then you could, you know, plug in the PIC microcontroller. So that's what I'm going to do. Bag of resistors. So I think I'm going to put all these in first. Okay, I've got the rest of the resistors and the two inductors in, and they go, pretty much everywhere. This is the Schlotsky diode. It took me a while to find it. Mind the polarity. All right. There's the crystal. Don't do what I did. Make sure you have enough slack so you can lay that guy down flat. I had to desolder him and put it back on. I didn't leave enough room. All right, we've got the surface mount components. They're large surface mount components. There's the voltage regulator and the speaker. Okay, we've got all of the capacitors on. We've got a whole bunch of these little ceramic capacitors, some of the larger ones. These three, the 100 microfarad 16 volts, didn't come in the kit, but those are pretty common, and I was able to find those at the local electronics store, no problem. Okay, we've got the MOSFET transistors. There's a T1, T2, T4, and T5, and then there's a bipolar transistor T3. He has a little bit different leads, and be careful because there is the temperature sensor. Looks exactly like this transistor, so you got to read the faceplate and make sure you get the right part for that slot there. All right, I think I've got everything soldered on here. We've got we added the switches, push button switches, and then there's a dip setting switch in the back. I think the only thing left to solder are the 6 LEDs for the tube lights, and they come in the back here and will sit like that, and you'll bend the leads over to these pads here and solder them down. So the leads are a little tricky. You have to bend them right at the base and then bend them again to go into the holes, and then you have to actually trim the leads. I kind of had to bend this one a few times, so this is the prototype one. Next ones will be a little neater, but it'll sit in here. It'll sit in that hole, and the leads will fit into here. And you solder those guys in, and do those for all the sockets. All right, so this is how the LEDs on the back side came out. Okay, we're ready for the first power up without the ICs. And when I plug this in, some LEDs should turn on. Let's see what happens. Hey, all right. Okay, all the LEDs are working. So we need to test the voltage on one of these pins. And if that voltage is okay, then we can plug in the ICs in the tubes. Okay, so we got to test at C17 capacitor, and the voltage has got to be between 5.1 and 5.3. That's here. And we're at 5.26. All right, we're good to go.
To get the ICs to fit correctly, you know, get something flat like a ruler. This is actually one of the edges of the case, and you know, you gotta mash the pins down. Do that on both sides. Get them straight up and down. Another tip, you know, get in there with the magnifying glass, and I'm not gonna get this in focus, but you know, check that those pins are in the sockets on both sides. You know, check both of those that the pins are lined up correctly before you mash them in there. Also very important, there's a little notch. The sockets have a notch, which we're on the left side for all these sockets, and then the ICs also have a notch, so you want to make sure that those are lined up as well. I gotta say, those were a little tricky. I thought I had them all seated correctly, but then I noticed some were lower than the others, and I really had to push pretty hard and rock on them, and they would actually do a little snap at the end. I think that probably had to do with maybe too much solder on the socket or something. So yeah, you want to make sure that they're really flush in that socket. All right, let's put the tubes in. Tubes are pretty tight in the socket, so you can't push them straight in, but if you just kind of give them a little circular wiggle, you know, hold the board firmly and just kind of give it a circular wiggle, and that circular wiggling kind of will seat them in, and you can get them flush in the bottom there. Okay, it's the moment of truth. Gonna do the first power on. Get all the tubes in. I've got it plugged in, but I've got a rocker switch down here. So I'm going to flip this on the power strip, and let's see if the numbers start to cycle through its test cycle. All right, it's working. All the tubes are working. We should cycle through to 9, and the LED should blink, and that's exactly what's happening. Fantastic. All right. Okay. Remember how I said I needed to go to the store and get some 100 microfarad 16-volt capacitors because my kit was missing those, which I did find and install. They work fine. However, these are too tall. I think these are 12 millimeters tall, and I checked the specs, and these need to be 7 millimeters tall. Otherwise, they won't fit in the casing. So the top of the casing comes across and bumps into these. So I need to pull these capacitors out. I've got some 7 millimeter high caps. So I will rework those, and we'll try to get this back in the case. I was able to get the capacitors out and clean up the solder holes with the solder wick. Let's see if I'll put in the new capacitors and see if I overheated anything. All right, we'll see if it still works after that rework. I'll test it with one tube. Okay, all right, life. Looks like everything's still working. All right, let's put it in the enclosure. Okay, here is the kit finished in its new home in my office. And let's see, we can see some of the display modes. When it gets to 50 seconds, it will display the date. That should be coming up. And then at 30 seconds, it'll display the temperature. Here's kind of a top view of the clock. There's a lot of different configuration options on the clock. It can be set for this leading digit as either on or off. You can have it blanked, or you can have it set for military time, date formats. You can set hours for nighttime mode where it runs where it's dimmer. It has blank hours, so if you want to turn off the tubes during certain times during the day where you're not looking at the clock to preserve life. Just a note on the enclosure, I mentioned I had to take the capacitors, put in the correct size capacitors. After I did that, the case was still rocking on something, and there's an LED power light. That was a little too tall, So I had to loosen up that solder and push that down a little bit. So make sure that LED, power LED, is flush with the top of the capacitors. Once you do that, fits in the case very, very nicely. And that's it. So this is the Numiqueen, a Numitron clock by NixieKits.eu. Here's the website. Jürgen Grau is the designer of the clock. I think he's based in Germany. And there you have it. I hope you enjoyed the build.